So speaking of sidetrack, see how I did that?
Nice segue.
So what are we doing? So today is levels, all about levels, and I just want to run you through the overview of the concept first. So in game Lua, back on line 84-ish, we have this section, and what it does is this line here loads up a script whose job it is to translate our level files into meaningful information that the builders can use. And I'll explain what that means in a moment. So level loader is basically more like a translator, but I called it level loader just because it seemed reasonable to call it that. So level data is a variable that will contain the information in one of these level files. And so, well, it'll contain the translated information from one of these level files. So levels itself will translate the contents and return a long table that can then be used by this loop and the builders to do the work. So just forget about this for a moment and pretend that level data now has the translated level information. I'll walk you through how that works. But the translated level information, it's all prepped and ready to go. And basically what we do is the first step here is we create a blank table. I talked about this at the top called pieces. So I put a table in pieces. And again, pieces, the job of that table is to contain the circles and squares here. And it doesn't contain the coins, it doesn't contain the player, it doesn't contain the spikes. It only contains the objects that we care about as gravity sources, which we talked about in episodes 1 and 2. Another piece of the code here in this game will iterate over pieces every frame, and it will say, is the player near to it? Yes, it's 100 pixels away. Is the player near to it? No, it's 200 pixels away. And it finds the one that it is closest to, and then it does some fancy calculations to apply a force between the player and the nearest gravity object. So again, pieces only contains basically our platforms, these silver bits here that we see on the screen. However, the builders, I decided to create them all with a uniform signature. So when you say signature, what you're talking about is basically the arguments that the function takes. So all of the builders take 3 arguments, but not all of the builders use the arguments that are passed. For example, the coin builder doesn't use the pieces table. So you can pass it in, but it just ignores it. So this loop basically iterates over level data, which is just a numerically ordered table. And I'll show you what it looks like in a minute, so it's not too confusing. And it takes each subtable. So this is basically a table that contains a series of tables, and each of those individual subtables is a definition that says this is a circle platform, or this is a spike that goes at the bottom, or a spike that goes at the right, or it's a coin and it goes at the bottom. Those details. So we take it and I do a little shorthand notation where I take the current one we're looking at, I assign it to data, which is just a local variable inside the loop to make my coding a little simpler. I could have not done that, but every place where data is, then I would have to do this and that. And I'm a lazy typer, lazy programmer, honestly. So typically when I am digging deep into a table and extracting one element, I will take that element and put it in a local variable inside my loop, and then use that to reference any fields or values in the table. It's a little bit quicker execution-wise, and it's easier for me to type it and understand what's going on. So extract the current element we're looking at, put it in data, and then determine which builder goes with that. Now I know it's a little bit probably confusing, but in a moment when we look at these individual elements, you'll see that they all have a field called type, and type will be something like square or circle or coins. And if you remember, at the top of game Lua, we set up this builders table with fields called player, round, square, coins, etc. These are the builder types. So our level table has a bunch of subtables, and each subtable has a field called type. Type refers to the builder script that is supposed to do the work, which lets us look up the create function for that one. So round create, square create. Hopefully this is coming clear for folks. I won't do it at this point, but I'll show you what these tables look like, and maybe it'll become more clear. So we've identified the builder, and I temporarily store a reference to that builder here in my builder variable. And then I simply say builder create. So I reach into the module that I've selected by its type, and I call its create function, and I pass in the layers. I pass in all the information for this particular piece, because the builders themselves still need to look at that record and say, oh, is it rotated to the right? Is this a spike that goes on the top? I mean, we don't know very much about it. What's the position that it's at, X and Y? All of that stuff is stored in this record. And then we pass in pieces for those builders that use it. So now, before we look at any builder code, let's take a look at how we lay out a level so that this all starts to become clear. So the final organization that I have settled on, I could have approached this in a few different ways. I could have created a visual editor where you could drag and drop, and I did that on a previous episode for another game. But I thought that in this case, because we're going to be working with a game where all the elements are on a fixed grid, they can only be at certain positions, that it would be easier to simply create text files, in a sense, that contain these level layouts. So the levels for all of the levels in this game are stored in an individual file, level 1, level 2, etc., etc. And within these files, it's a typical copyright statement and some comments at the top. But the interesting bit is we create a table in this file called level. Could have called it anything. Empty table. And then in this table, I create 3 subtables. I create a subtable and I store it under platforms. In this table right here, under platforms, I create another one called dangers, which is spikes and other things. And then I create another one called other, which is the coins and the monsters, because the monsters, although it sounds like a danger, they are actually our goal. We want to get to the monster, so they are sort of like the others table here is designed to contain pickups and all the good parts of the game. Platforms is just what it sounds like. It's the circles and the squares and the bits that we're supposed to jump on. And it also contains a marker for where to put the player at the beginning. To put the player for that level. And then dangers is all the other bad bits that we don't want to touch. So if we look at these files, I decided when I did this game, and you could change this later, I decided to make, let me find it. I decided to make the levels 8 by 8 grids. So they're 8 across, 8 down. 64 locations where a platform could be. I could have made this anything I wanted, but in the interest of legibility and tractability, the ability to understand what I'm talking about and showing you, I wanted something that I could easily display while we were talking. So what I've got here is a platform of tables where if there's 1, 2, 3, 4, 5, 6, 7, and 8 across, but I just laid it out like this so I could read it. Then I have a comma, and it goes down to the next line, 8 across, and there's 8 columns and 8 rows. But really, when this gets loaded, this is one big long table with 64 entries. So at some point, although it looks nice here, I did this so that I could sort of, in my mind, say, oh, this is the upper left corner, this is the lower right corner. This is row 2, column 6, and this is row 3, column 1. So this is purely laid out so that we can look at it and say, okay, this is where our guy starts. There's going to be a round one here, and load it. Here, our guy starts, and there's a round one here. No, I wanted that to be a square. Okay, squares are S. Okay, so we put an S, and we reload it, and now we've got a square. So this visual representation corresponds to the way I laid it out in the file.